to the third Fab Lab here at NCECA. This is the third year of a 3-year project. My name is Kelly O'Bryant. I'm the coordinator of the Fab Lab here, and I also teach at the University of Dallas. We'd like to thank our sponsors for the Fab Lab. Behind every technological thing, there needs to be a few sponsors. So we have Brackers and Scut to thank for that. And of course, West Virginia University, who started this, the idea in conjunction with NCECA for the Fab Lab. I'd also like to invite you to check out the show if you haven't already, which is just outside in the atrium, and check the schedule for other presentations to come here in the Fab Lab. I'd like to introduce you to Joe Cam, an artist, designer, educator, and engineer working in and around the field of digital design, and fabrication. Joe studied ceramics at the Kansas City Art Institute and the New York State College of Ceramics at Alfred University. He has participated in artist residencies in ceramic centers in the US, Hungary, Poland, and Denmark, and lives and works in Kansas City, where he currently specializes in digital and parametric design as a project engineer at Zahner, a fabrication company specializing in artistic and architectural work. Enjoy the presentation. Thank you, Joe.
Thank you. I actually want to start by thanking Kelly. This talk kind of is only happening because Kelly and I got into a conversation about it, and she said, wow, this is great. Please come talk and tell more people about it. And I'm actually one of many people talking about this issue, around this issue, of how to make technology more accessible and easier to get involved in ceramic education. It's sort of a question for me. Like, I love digital tech. If any of you were here for my talk this morning with Keith Simpson, you can see that we love computers, we love working in technology, we love the robots, all of that. But it's not for everyone. And it's sort of this question of, like, how do you get people involved and make it not seem so complicated, not so hard to get started, or to rate, like, the bar is so high, you need to know so many things. So I came up with this theory, this argument, as an alternative to that. It's based on the work of a lot of other people. I was really inspired when I was at NCECA 2 years ago, and there was a presentation by Holly, how do you pronounce her last name? Hannison, and her students at FSU. And then also Brooks Oliver talked something about this, the idea of using 3D printing to make tools. And that's what this is really going to be about. OK, so when people start talking about technology, it's like, oh, well, why don't you like using it? And some people say, oh, it's too easy. It's cheating. Like using robots, using 3D printing, oh, that's like way too easy. They're lying or they're wrong. Digital technology is really hard. And you saw that this morning. There's so many things that go into it. You have to figure out so many problems. There's so many new problems that we're discovering. It's a really exciting time to be doing this because there are so many problems. But it's also really daunting, and it's especially daunting to bring into ceramic education. So this is the list that I put together of the reasons why it's hard to put it into practice in a regular ceramics curriculum. This kind of comes out as a master list. And the first thing is machines, money, whatever you want to call it. It's the startup fees, the startup costs of creating a ceramics program, whether it's the machines or the software, whatever it is. It costs a lot of money. To talk specifically, this is the class that I taught at the Kansas City Art Institute. And when we're talking about money, we're talking about a CNC router that was over $50,000. We're talking about software licenses that may be a few $100s each. Not to mention 3D printers, all of that. That was before the school spent a few $1 million on building a fab lab. So that's a big, like, how do you get involved in that when it costs that much? Then our access, because we're using professional programs, we're in library computer lab that has limited hours. There's a limited number of licenses at the school. The tools are in a central shop. You need a technician there to use them. And we had all these spaces. We had the computer lab and the central shop and our ceramics studio. Sometimes you don't have that many spaces. And even if you do, have you tried teaching in 3 different places at once? Like to students who are all over the place? And this is, I'm talking about this in a ceramics context, but also think about it in your own practice. Do you have 3 spaces to do your work, to do all of these different parts of this process? Time. It's taken me a long time to learn these things, and it takes, even when, with all of the experience that I have, it takes me a long time to communicate this type of information, teaching Rhina, whatever it is. And then the experience that you need the experience that you need to impart to a student before they can actually get to a point where they like something that they make. And that's one of the things that it really comes down to. When you look at a lot of digital work, there are certain signatures of digital work, and that's because of the way it's made. And that's interesting if you like that, but if you don't like that, how do you find, like, where's the space for people who don't like how that looks? Is digital still useful to you? And the question is, can it be easier? Can we make it a lot easier? Can we get rid of all of these things? And that was my challenge. I was asked to teach 3D printing in clay in 1 week. And all of the traditional ways that I had been looking at 3D printing, of making models, then making molds, then casting them, or printing directly in clay, those take so much time, not to mention like not even the time that it takes to teach how to do those things, but then to get something out of that process, you really have to strip it down. It has to be so simple that it's going to work, because you want it to work for people for the first time. But that means that you're not taking risks. And what's the fun in that? Like, we want to try things out. We want to push things. So digital tool making was my answer. And I'll explain what that means. I'm going to use the 4 projects that we used in this class to kind of explain different aspects of what I mean by this theory, by this idea. There's stamps, texture rollers, extruder dies, and cookie cutters. And I'll use each of these to illustrate something about this. One quick moment just to talk about the tools. 3D printing. I used to not really get what it was about, but it turns out it is a fantastic tool for digital fabrication. And one of the big reasons for that is safety. And so this part of this question about access is the tool safe? Does it need to be supervised? And one of the great things about 3D printers is maybe you can like burn yourself on the extruder tip, but other than that, it's not going to hurt the user, and it's not really going to hurt itself. It's kind of hard to irreversibly break these machines. And they tend to, when they mess up, you can see over here, there's a giant spaghetti mess. But you can leave it overnight. Here's a 10-hour print that was just sitting there overnight. That's great. You can just let things go. You don't have to be there like with the CNC machine and watch it the whole time. I've had students who have done 8-hour projects where they are sitting there for 8 hours watching the machine, because that's what you have to do. And you have to wear safety glasses and all of that. 3D printers are just safe enough that you can leave people alone with them, that you don't need to be there, and that you can leave them running on their own. They do take a lot of time, and because of that, when you're teaching with them, you want to generally limit the scale of what you're doing, because you want it to be small so that it's fast, and it's also just, there is a limit on how big it is. So if you're making final objects, your final objects generally aren't going to be bigger than the 3D printer itself, and that's pretty limiting also, because we work in ceramics. Sometimes we make big things. OK, so our first tool is a stamp. And this very quickly addresses those first 2 items on the list, the money and the access. Because to do this project, I use Tinkercad, which is a program that is free. It's online. You don't even need to download something to use it. So the students are able to use it. If you're teaching them doing a demo in a lab, that's great. But then they can do it in the library, in the public library, wherever it is that they go. they can use this program and they can still have access to their files because all of the information is stored on the cloud. Makes it really easy to share. If they want to turn in an assignment, they just hit a share button, send it to you. And the other great thing that I love about this program is that it teaches you how to use it when you open it up. It has a series of tutorials that get through the basics. And so if you're in a classroom where you have students who are really wanting to go ahead, they go ahead. If you have students who kind of need to recover, like review the material, then they can go back to these tutorials and look at these basic things. The other thing that's amazing about it is that this 6-sided die is one of the tutorials. And that is exactly what this stamp is. That's all that it is. But instead of numbers, you're just putting shapes. And so it's a built-in project to this program. OK. Sorry, this is the first time I've ever given this talk, so a lot to cover. OK, so I'm not actually going to be demoing this. If you want to see a demo on this, then come back tomorrow between 2 and 3:30. Elizabeth New and Shalaya Marsh are going to be doing an hour-and-a-half talk about 3D printed tools, and they're actually going to be demoing this stuff. I like to think of what I'm doing more as like postcards. So I'm showing you all of these places. They're going to give the guided tours. So please do come back for that. OK, so this is actually pictures from one of those classrooms. One of the participants of the workshop took this back to his classroom. And this project works great to teach 3D printing because it's small and it's fast and it's versatile. So even though you're making a stamp, even though each person is making their own stamp, these can become a library. So that even if you don't have time to teach 3D printing with one of your classes, you can keep a bucket of these stamps, and your students can be introduced to the idea of using 3D printing, of using digital design to make their own. So they start with something, and then once they have time to, once you have time to, they can come back to that and actually make their own tools. It also is easy to share because they're generic enough that you can do different things with them. Oh, yeah. So that's the next one. I thought I had a different slide. OK. So then we move on to the next one, the texture roller. So one of the great things about this class, I already had printed some 3D printed tools when they started. So we only had a week, but they started on their designs. They started printing their designs, and they immediately went into Studio and started making things. Clay is good for this intuitive kind of just making stuff. I didn't anticipate what any of these people were doing. They were all people who had experience with ceramics, and so they just went and they did all of the things they knew how to do with ceramics. They just used these tools. That's what ceramics is good for. What is digital good for? Why bother with this when you could just use bisque rollers? You could use bisque stamps. You already know how to do this stuff. Making tools is not new to you. But digital does have some distinct advantages. Over here on the right, you can see that there's a positive and negative relationship that you can very easily do. And I'm going to show you that in here. OK, let's make this happen. So wait a second. Yes. So there's one thing in in Tinkercad that they don't show you in any tutorials, and I'm going to show you that. This is one of the things that makes digital great. Digital is good at replication. It's good at symmetry. And it's good at, what is the last one? Yeah? Positive, negative. I think I already said that. OK, so this duplicate tool, it's up in the upper left of the screen when you're using it. It's over here. And this is Tinkercad. I'm just going to speed this up a little bit. OK, so you take something, and it not only duplicates the object, it also duplicates the actions. So here, I've moved it and rotated it. But every time I press that duplicate button, it moves it the same amount and rotates it the same amount. And this is something you can do with any sort of shape. Here I'm doing it to stack something, but you can very easily do that to do something that's round. And if you do that in increments, like if you move it an angle that's within some exact whatever divisor of 360, then you get a seamless texture roller out of that. And so here I'm aligning these parts, and then I've got these two things. So let's pause this one or move on to the next one.
In real time, how long did it take you to do it?
To get it right, once it was working, it only took a couple minutes. But to get it good for this little presentation, making videos, I'm not about to do that again. Yeah, especially since now I have to find it again. OK. Where did I put it? OK, yeah. So here's one more example of that. So just selecting two things, you duplicate it, you rotate it a little bit, you keep on rotating it around with this duplicate tool, and now you've got something that looks pretty complex, but it's actually pretty easy to do. And doing things very exactly is one of the things that digital is great at. OK, the other thing that digital is really great at is this positive and negative relationship. In Tinkercad, it's really simple. You just call something a solid, or you call it a whole, and then you group them together. So let's look at that. Where did it go? Nope. OK, well, we're not going to look at that right now. But it's really simple. And it's so simple that when you're done with it, you get these two things. I mean, you can see the shapes over on the right. This is a positive and negative of the same design. Once you have this file, what do you do with it? This is in Cura. Cura is the 3D printing program that I use. And digital is amazing because there's just certain things that are so easy to do in there and so hard to do otherwise. One of these is scaling, and the other one is mirroring. Mirroring is just making a symmetry of something. Doing that in digital is so easy that I was talking to someone at the Smithsonian. They actually had a huge, almost fiasco because they 3D printed an ancient skull, but they printed it backwards, and it was going to people doing research, and they had to rush and reprint and send it off because they were about to do groundbreaking research on a mirrored skull. So we can use that to our advantage. We can just make designs that are mirrored very simply, and it's something that's hard to do otherwise. And then scaling is another one. Making something, but just making it a different size. These are things that are built into the printing program, not even the design program. Just to change the size of something, you scale it. You scale it up or scale it down, but you don't have to do that in all 3 dimensions at once. You can also just scale 1 dimension. So you can have your one design that's this over here, and your other design that's the same exact thing, but 1.5 times taller. Or you can make it 1.5 times wider, and you can have an elliptical roller. And that's kind of interesting. That's not something that's easy to do. OK, the last thing, next thing, maybe the last thing, that I will point out right now for what's good about digital is sharing it. And so this is actually the designs that I was just showing you. They are available online. The site is Thingiverse, and the name of the account that we used is called Plastic4Clay with little number 4. And this is where I put my designs, and the participants of the workshop put their designs. And then when they got home, they were able to print them for their own classes. And so this is actually Nick over here. He bought a printer after this class, and he printed these out and shared this picture with me. These are the texture rollers that his class is using. OK. And then, yes, of course, you can take all of these, and you can change them. You can customize them by taking them just into a 3D printing program and changing their size, or changing, mirroring them, or doing something to them. OK, the next thing, the next tool. Extruders. I've always been interested but mystified by extruders. And I don't really know how to make interesting work with them. But when Brooks Oliver talked about making a 3D printed extruder die, I was like, oh, yeah, that has to happen. But I didn't know how. And so I tried a lot of things. And what I came up with was this design. And it's important for a couple of reasons. One of the things that I discovered is that 3D printing an extruder actually takes quite a bit of time. It is a solid chunk of plastic that you want to print a little bit more of because it's going to be under so much pressure. So my first thought was, oh, make it with a bunch of different shapes that you can just pop in and pop out these little parts so that you can do a bunch of shapes at once. But if you're doing this for a classroom, then what you really need to do is just make the part that's custom a lot smaller. So you have one part that's the same for everyone and another part that you do custom. And this is one of the critical things about 3D printing. Don't make the whole thing. Don't remake the world. Just make the part that you need. And make the part that it works for. I mean, trying to bridge across in 3D printing is just not strong. So use bolts. Bolts are good at that. And they're standard sizes, so you can just drill a hole that's 1/4 of an inch and put a bolt in that's 1/4 of an inch. And it's really strong. And it makes it so you can take it apart. You can clean it, and you can also put in a different shape. This one is also available on Tinkercad. All of the things that I'm going to show you are on my website, so don't worry about taking notes or anything like that. I'm going to show you my website at the end, and all of this information is there. So this is one of the first extruders that I was really excited about, making like a little cinder block. And it's like, there's just so much that's possible to do with this. I have no idea. And I think extrusion is actually really hard, like designing good dies. But this is a great way to kind of like explore that territory. Not knowing really how they would be used, I was really excited to see how people put them into practice. So there was one person hand building with them, and another person like making these into little ladders. It was just great to see how people used it. The other thing that came up is a lot of teachers just said, well, I don't have a North Star. That's what it was designed for. I can't afford that in my studio, but I can get one of these handheld ones. So how do we design little dies that work for that? What is something that you would want to use? And so this is Nick's design for a striated coil that he used just for some designs. And then over here, Elizabeth, she did a handle extrusion, and then she was able to attach that to her cups. OK, tool number 4. This is the last tool, but this is also the one tool that kind of encompasses everything all at once. You can look at this, and it sort of embodies all of the lessons of what I'm trying to talk about. So the things that we're looking at, just to remind you, this kind of master list, we're thinking about what does it cost, what is the access to use these tools, how much space and how much time does it take to do this, what kind of facility needs, but also what kind of curriculum needs. Do you need to put aside a month, or put aside a day, or put aside a semester to get something done? And then experience. How much do you need to know in order to make something cool? And lastly, the reason. Can you do something with this that digital allows you to do that you can't do in any other way? Is there a compelling reason to use digital? And I think this one has all of those. This is basically it. It's these really just 2 programs, but 3 programs because you have to print it. Again, I'm not going to demo this. If you want to see a little bit more about that, come to Liz and Shalia's lecture tomorrow between 2 and 3:30. But this is super simple. This is an app that I worked on with a mathematician developer in Kansas City. I tried to teach tessellation using Rhino, and it was impossible. I tried to teach tessellation doing it by hand, and it was painful. But he created this app that is super, super simple, and you just drag a line and pick what type of tessellation that you want to do, and it creates a full, like a full pattern for you, just right there, right away. And then with this program, with Cookie Caster, you take a screenshot of that, and then you go in and you automatically trace that shape, and now you've got a cookie cutter that you can download, that you can print, that you can do this whole process in probably less time than I just explained it. This has hands down been the most popular project of the participants in this workshop. I asked them for pictures of work that they're doing, and so many of them sent back, I'm doing this with my class. And Lacey, I was amazed by this. She didn't even have a 3D printer, so she just printed them out on paper, had the students trace them. This is a great adaptation of this project. And then she brought it to an educator conference and said, hey, look at this thing. You can make these things really simply and then use them to talk about surface treatments, to do some sort of repetition project. And it just becomes some small project, part of a much larger project. And I think that's what tools really do. They kind of fit their way into what we already know, into what we already do, and they don't get in the way. They allow us to use all of the skills that we're teaching in ceramics and build on those skills instead of necessarily getting someone outside of that zone. So what are the risks of doing this? I'm saying make it easy, but there are risks to making it easy. First of all, we're not really giving people all the tools to make everything. And second of all, I like to think of this as public transportation, because when you have an app, it does one thing really well. So it's kind of like a bus, and you can go exactly where that bus goes. You can go exactly where everyone else wants to go, but you can't go anywhere else. And so how do you deal with this problem of making something that's both really powerful but also really limited? That is, Tinkercad's pretty powerful. It's a lot more like the Boston subway map, where you can get a lot of places. Maybe it takes a long time. Maybe it's not the most efficient way to get there, but you might not have a car. But the Kansas City streetcar kind of just goes one place and kind of only goes 1 mile. So how do we make it still useful for us? I really like this project that Elizabeth Phelpsmeyer did. And she just took this cookie cutter, and she was like, oh, no, it's just a pattern. So she had her students working with it as a surface treatment to divide it up. And then this other project, this wasn't even ceramic. The educator here, Holly, she just used the app to do a completely different project. She took one part of it and made it meaningful and useful to her. And so that's what I want to see, is like these tools, they're intended, I'm presenting very specific uses for them, but they can be used in so many different ways. My other concern is that it would feel limiting. It would feel obvious. But I got an opportunity to teach a workshop for the Kansas City Art Institute, and it was their junior class. And my workshop was 3 hours on one day. And of that, about 15 minutes of it were teaching this design program. And then the rest of the time we were talking about tessellation. We were spending the time talking about the issues, talking about the history, talking about how tessellation works mathematically. These things that we want to spend time on in our classrooms. We want to spend the time talking about whatever it is, the project. We don't want to necessarily get bogged down by the process. And then also, just this work was so beautiful. I loved how it came out, and this different use in the same tile of using it for a continuous line design and then using it for a surface pattern, the way that they did things in and out of plane. My goal, and the thing that this really realized for me, is that this is invisible. The digital part of this, you wouldn't even know, you don't have to know that it's digital to appreciate it. The other concern that I have about, oh, it still looks good. The other concern is that it's limiting, because it's doing everything for you, so does that mean that you're not going to do anything on your own? And I think that Lucas's work here really demonstrates that that's not the case. And so Lucas got really interested in the app, and he made the tiling on the right, but then he also was taking a Rhino class with Paul Donnelly, and he did the one on the left using a CNC router, using typical, like the mold making, some of the strategies that we've talked about. And he really demonstrates how these tools can be a ramp instead of a blockade. You know, it gets you very far, but if you want to get farther, maybe you get excited to learn these programs. Maybe you get excited to take it to that next step to do exactly what you want it to do. So we did it. 3D printing and clay in 1 week. We had fired work for the exhibition on Friday. It was crazy how much we got done. I have some additional things I wanted to say about this. What were they? Give me 1 second. Not that, not that. Cool, we're almost done. OK, so reviewing that list that I kind of started with, this idea of a master list, we printed, we had 4 printers. There was a total of about 100 hours of printing, I think. Maybe it was more. But we did it for like $50 of material. Like 3D printing is really cheap. The access, they had the software so they could use it, like that tiling app thing. You can use it on your phone. Like you can like teach it in a classroom, whatever, but then they can use it wherever they have a computer. And they had full access to these 3D printers because they were safe to use. The space and time, I told you, we started on Monday, and they didn't have, some of these people had 0 digital experience. And then by the end, they had finished work. And then experience, I think they did things that they were excited about. And the reasons, like why do this? I think we came up with some compelling reasons. So this was Jared. Is Jared here? Jared's somewhere at NCECA. But I really liked what he had to say about this because it kind of just sort of embodies it. Oh, we are short on time. I will talk faster. So yeah, he just realized that you didn't have to sit in front of a computer in order to get all of this done. And he's picked up these tools and used them in ways that I hadn't anticipated. And that was just great. So the next time someone said this is, that's easy, then like what I want to hear is like good. Like it should be easy. It should be easy to get started in this. And that can take you to the next step. But we need it to be easy in order to get students excited, in order to feel like it can go into our curriculum without being overly burdensome. It kind of needs to be easy. And then once you've made it easy, that's where we can start to make it hard. I say that digital technology and all of these things that people call cheating, it's not about making it easy for yourself. It's about asking yourself harder questions, giving yourself the opportunity in this space to think about other things because you're allowing the digital to take on certain roles in what you do. So that's really, that's most of what I have to say. This is the information that I just told you about. My website, joecam.com/teaching. Go there for more links, and there's actually, my whole curriculum is on there. You can take anything that you want. Give me credit if you would, please. But use it in your classrooms. My idea is that if any of you wanted to incorporate digital technology in your classroom next week, could you do that? And I think that there's some opportunities here that you can get that done. And yes, please, definitely, go see Liz and Shalaya's talk because they're actually going to show you what this looks like. And it's going to be a lot more fun. And that's going to be tomorrow. So thank you to all of these people. Thanks to all of you. Do we have time for questions?
We have time for a few questions. Let's try to take some.
Before we start our questions, I actually want to call down Nick. If you would come down. Nick's actually one of the participants in the class. And you saw some of his work. And if you have any questions for him about actually using this stuff in a classroom, he's probably the best person to answer that.
Great, thanks. So if you would just speak up if I can't get to you or if I can't. Thank you, Joe.
Which machine do you use to print? Do you, the one that was in the picture, like what is that? Which 3D printer is that?
It's called an Oni, and it's a guy near Kansas City. He designed it. He sold it to the Art Institute. Like, I built them with him. We actually did a class where we built them, so the kit itself was about $1,000. Very reasonable for a 3D printer. ONI, and I think that's the same printer that Nick has. Yes. Can you avoid blocking the camera? Sorry.
I've been using 3D printing in my classroom as well. The problem we're running into, especially when the print is indented, and then press it in the clay, it doesn't always come out, it doesn't always release well. So to press it in is fine, but when it's, you get the elevated part in the clay, do you have any recommendations? We use cooking spray, we use baking soda.
Have you tried Nefsi?
No.
Okay. Nepheline cyanide. I sort of used it as like flour when we did the cookie cutter thing, because the cookies stick too. So using that as like a little bit of flour on and then cutting with that, I think that worked pretty well. And cornstarch. I mean, clearly that is one of the secrets of ceramics. So, other questions? Yes.
Can you speak to the fragility of some of these things? Like, what breaks?
What breaks?
Yeah, because some of yours were really thin. I was surprised. And I've had wood break in extruders.
Yeah, I mean, I've broken some of these, but I changed the design also. I added a lip to this to make it stronger, and you can change the fill of the print to make it more robust. But these, like, you can stand on these. I mean, there's not much you're going to do to them. Nick, you had something that you had told me about right before the lecture about using the 3D printed tools?
Yeah, first I want to say I enrolled in this class at the Kansas City Art Institute as an educator's, those summer courses they have. I thought we were going to be working with clay. I had no idea. But it was by far the best class I've ever taken. Joe's an incredible teacher, and it's changed my trajectory as a dad. I have 2 young daughters. My 7-year-old has Tinkercad and Thingiverse downloaded on her tablet. She designs stuff that I could never envision. But my school, we practice inclusion with special ed, and that I would say has been the most dramatic, or just the wow moment, is how these tools have affected my special ed students. And sometimes it's just that there's positive and negative, how they roll together. Sometimes it's watching a long print. I think you guys know what I'm talking about, that I couldn't have predicted that, because I was thinking about all this high-tech stuff. I was somebody that could not rotate an image on the computer, an object. I had 0 digital experience, and so I'm one of those guinea pigs he was talking about. So I just want to thank Joe for sure.
Thank you, Nick. Yeah.
I have a quick question. Did you print each one individually, or did you try to print a couple of them at the same time on your 3D printers?
We did a few at a time. I printed all of these at once, and then this one failed. And so I reprinted it on its own.
Did you mess up the other ones when it failed?
No. I mean, sometimes it does, but all of this together, I think this is maybe 100 grams of material, which is about $1.50, with the kind of filament that I buy. And even the most expensive filament might be $5 of material. So there's a really low cost to that.
My students also have gotten online. There's this designer in Amsterdam named Yaris. You'll see a lot of his designs on Thingiverse. And I found this community to be very open source, but very sharing and very, I've asked a lot of stupid questions, and everyone is always very giving and also sharing their files. So this guy from Amsterdam has been sending my students his files, and then they've been printing them and making molds and casting ceramic objects off of his designs. We give him credit, but that's the other part of this, where the file sharing can be done digitally through email or whatever. you can send someone your mold design, which I think is something I never experienced before.
Kelly, do we have like 3 minutes? Okay, do you guys have 3 minutes? Okay, then we move on to the bonus section. Okay, so this is something that I just discovered. I was really excited to share it, but I didn't know whether or not I'd have time. My question was, could you take this tessellation tool, like we've got it, so we've got a tessellation tool and another tool that helps us make a cookie cutter. So what do we need so that we can make it a texture roller? So we can have tessellating texture rollers. That would be awesome. So the way that you get to this, you guys probably know what a lithophane is. Maybe you've seen some, like the long history of it in ceramics. It's really hard, it's really beautiful. It's really easy with digital because all you're doing is sampling each point for whether it's light or dark and translating that to a thickness. So I took one of those tessellating designs and I took it into a lithophane program and I made a little texture sample thing. That's great. It was super simple because now you're working image-based. So instead of doing your 3D design in a 3D program, you're just using images. And your students know how to work with images. So then, could you get a texture roller out of this? This is a program that does this for you online. It's another one of these apps. And then, if you look right here, there's a cylinder option. And now we have a tessellating texture roller. It's that easy. There's a little bit of trickiness with the getting the image to line up right, but otherwise, like, there you go. So now I added one more right there. So now you get the 3DP Rocks. That is the website to go for that. So thank you all so much for coming. I really appreciate you being here, and I hope that you get an opportunity to use this stuff in your classrooms.